Okay, so today what we're going to start looking at is the graphs of the rational function. We've been looking at how to simplify rationals, how to multiply and divide rationals, and then lastly we did how to add and subtract rationals. Now we're going to kind of leave that alone a little bit and look more at the graph for the next few days. Okie doke? Okay, so remember a rational function is, all rational means basically is, a fraction. Okay, so like right here, they're showing it's P over Q. Okay, and they're polynomials. P and Q are polynomials, so they look like algebra. Then the graph of a simple rational function, so this is kind of like the parent function right here. Okay. And here it is again, the parent function, just 1 over x. Okay, so we have some new terminology, and we have a new little item today. These red dotted lines are normally invisible, okay? But you'll see them dotted on a lot of graphs, okay? And they are called asymptotes. Asymptotes. I like to say that. I don't know why. It's kind of a fun thing to say. Okay, they're called asymptotes. And what an asymptote is it's kind of like a shield. The graph can never, ever, ever touch the asymptote. Okay? They kind of reflect and push away the graph. So, and what's even weirder about an asymptote is, I'll just kind of show you over here. Well, maybe I can show you on, let me show you on a blank piece of paper over here. Okay, so what's weird about an asymptote is, let's say we have an asymptote right here. So that means the graph isn't going to touch that red dotted line. So here comes the graph. An asymptote, this graph gets closer and 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 closer to this asymptote. They keep getting closer and closer and closer and closer and closer and closer and closer forever and ever and ever and ever and ever and ever and ever, but they never touch. It's like, how in the world is that possible? You know? It's just hard for me to even imagine. They just get so microscopically close, but they never touch, even though they go forever. I mean, that is crazy, isn't it? It's kind of like the opposite. The universe just keeps getting bigger and bigger and bigger and bigger. How is that possible? So this is kind of the opposite. We're getting smaller and smaller and smaller forever and ever and ever. Okay? So that's just weird. So don't think about it too much or you'll drive yourself crazy thinking about that. Okay, so back over here. So that kind of helps you understand what an asymptote is. The graph never ever touches it. So, and when you look at this graph, it just looks like a big mess. You have to sometimes stop a minute and make your eyes find the x and the y axis, okay? And I'm probably not, let's see, I shouldn't even been on that page. Let me go back over here. Okay, so you have to look sometimes, and as you noticed a minute ago, and have your eyes find the x and the y axis first. Then go find the dotted lines. The dotted lines are not the x and the y axis, they're the asymptotes. And sometimes the asymptotes are not even drawn in for you. But if they are, they're going to be dotted lines. Okay, so I guess that's all on that page I want to say. Okay, now this is a very super duper important little formula here. It brings back our wonderful friends H and K. Y'all remember what H and K do? Okay, what does H do? It moves the graph which way? Left and right. I don't know if y'all remember, but at the beginning of the year, I said, we're going to use this all year. If you'll learn H now, you'll be good. Okay, what does K do? It moves the graph up and down. Okay? And so that's what they're saying here. And once again, H is a liar. When he's in the equation here, he's a liar. When he stands by himself, he's not a liar, and I'll explain that in a minute. I'll have an opportunity to show you what I'm talking about there. And then K moves the graph up and down, okay? But he's not a liar. He tells the truth. Then, the reflection here, okay? If you'll notice, let me go back to this over here, okay? If you'll notice the graph, which is the black part, it's in kind of quadrants 1 and 3. But if the graph, whoops, making a mess of this, if the graph is not kind of in quadrants 1 and 3, but more in 2 and 4, then that means it's been reflected. So the A would be a -1. And so our A is this part in the front of the little formula here, the equation. Okay, so let's look at this guy right here. Okay, so you kind of have to make your eyes find the X and the Y axis first. So it's been moved. It was here at the origin, but now it's moved over here. Where the asymptotes cross is a good kind of a base point, to reference point, I guess I might be trying to say, to be able to tell how the graph moved. Okay, so our asymptotes are crossing right here. This is the horizontal asymptote. This is the vertical asymptote. So how did our graph move? It moved to the left 3, didn't it? And it moved up 2. So our H would be what? Yeah, well, our H is really a -3, but when we put it into the formula, it becomes a +3 because the formula has a minus in the front. It says to do the opposite of the H. Okay? Then, what is our K? Our K is 2. Okay, and notice they have the K here, and they have the H here. And notice those are the same numbers that make your vertical asymptote and horizontal asymptote. So VA stands for vertical asymptote, HA stands for horizontal asymptote. Okay, you've got to know which way horizontal is. Horizontal is flat, vertical is up and down. Okay, last period, kids were kind of confused about which letter to use. Well, there's a couple of ways to know that. Look at your vertical asymptote. It is cutting through or intersecting the x-axis, so you use an X. The horizontal asymptote, okay, is intersecting the y-axis, so you use a Y. Another way I remember that is vertical of V, if you extend it, makes an X. Okay, so vertical, use an X. An H upside down makes a Y. Okay, so you can remember it that way. Okay, so they kind of came up with their the equation by using the H and the K and plugging it in here and here. Then our A is 1 and 1. Okay, so you find where you look at your graph and find where it's crossing the grid line perfectly, and then that helps steer you to find the A. Okay, and we'll talk about that more in a minute. So if it's right here, just at 1 up and 1 over, the A is 1. So that's why there's not really anything right here. Okay? Okay, so let's look at this one. Come in. Okay, who do you need? Oh, okay, let's see. Okay. Okie doke. So this one, we already talked about it a little bit. I think this one, I don't know. It's been reflected. Normally, the graph is here and here, right? So it's been reflected. And that's all they're showing us right here, that it's been reflecting. So an A in the front would be negative, and that's why they have a -1 on the top. Okay, down here. Okay, let's look at this guy. Okay, if the A is greater than 1, it's a stretch, and that's always been the case all year long. Our A is 2. So you go over 2, up 1. So you kind of go, normally you do rise over run, but it might be better to do your left and right first. Kind of go left and then, or go right, whichever way, whichever direction, and then up. So that's 2 over 1, okay? So our, I guess you would get it that way too, 2 over 1. Okay, so that's how we got our A. See, notice it's not right here. For the parent function, it's right here. The graph would be going through right here at 1, 1 for the A. So most of ours on our worksheets, the A is either 1, it's 1/2, or 2, or 3. I don't know that I've seen a 4 on one of our worksheets. So you don't have that many choices to choose from, so I think you can get the A right. Okay, then if it's a compression, y'all know that the A is a fraction in between 0 and 1. Okay, and so here, okay, you go over 1 and then 1/2, up 1, over 1. So it's 1/2. Okay? So you're going up, you see you're not going up a whole. Normally this is the normal place that the parent function goes through. So it's lower down, it's closer in, it compressed. Okay? And so it's 1/2 right there. Okay? Okay. So let's look at a couple of actual problems. Okay? So first of all, make your eyeballs kind of look and find the vertical and horizontal axis. And then you can see the asymptotes. So this graph moved from here at the origin to here where the asymptotes cross. Okay? So how did it move? Who can tell me something about its movement? How did it move? Okay, it went to the right 2. And so is that our H or our K? That's our H. So H is 2. It's going to be a -2 in a minute when we put it into the formula. Okay, but it's not quite there yet. We haven't got to down here naming the function yet, the equation. Okay, how did it move going up or down? It went up 4, and that's our K. So it went up 4. Now let's see if we can figure out what the A is. Okay, so looking here, from here to here, what did it do? Or from here to here? How many? Yeah, up 3 over 1. So the A is 3. Normally, this line, this black graph would be smushed in here. Okay, it would be doing this. And so it got stretched out. Okay, it got stretched out. So you know your A is going to be bigger than 1. Okay, so now, where is our horizontal asymptote? Y equals 4. Okay, that's our K value. Okay, K value. Okay, what's our vertical asymptote? Here's vertical. Vertical goes up and down. Yeah, it's going through the x-axis. X equals 2. Or take a V and extend it. That makes an X. Take an H and turn it upside down. That makes a Y. Okay, we have everything we need now. I think you can see on your worksheet, you can see that little formula, but I can't. So I'm going to write it down. It's A. You don't have to write it down if you can see it over there on your worksheet. X minus H plus K. Okay, so usually, the second function that's been moved, we usually start it with a G. The first function, the parent function, is the F. So what is our A? 3. We're just slotting it in. We're just plugging in this A right here. Okay, 1 over X minus, what's our H? 2. And see, it did. It became a minus 2, didn't it? So when it's in the formula or in the equation, it becomes a liar. It's the opposite. But when you're just naming it, you make it tell the truth, the H. And then we say plus 4 out here. Okay? So this is your H. This is your K. This is your horizontal asymptote. This is your vertical asymptote. Now, let's talk about the domain and range. Excuse me. Okay, let me go over here again to this blank page. Okay, so, because last period they kind of needed a little clarification on this. Okay, so let's just take this part of the graph. We know there's a, let's see. Let's say this is at -1. Let's say this is at +2. Okay. Okay, so the domain, okay, it's going to be all real numbers. Okay, so we have another part of the graph doing something like this. Okay, so the pink is the graph. Okay, so where did this graph come from over here? All the way over there, right? Yeah. Okay, yeah, it came from -infinity. And here it comes. Here it comes. And here it comes. Okay, it gets over here. Now, what happens at this asymptote right here? Can it touch this asymptote? This asymptote is at 1, isn't it? Okay? But then, so it kind of has to jump over the asymptote, and then it comes down here, and it gets right up next to the asymptote, and it goes forever this way, doesn't it? So it's from -infinity to 1, but it's not equal to 1 because that's the definition of an asymptote says it can't equal 1. Then it picks up on the other side of 1, and it goes to infinity. Okay? That just kind of means in union with, like, and also. Or another way to write it would be it's all real numbers except x can't be, oh, this should be -1. Can't be -1. Okay? So your domain and range is all real numbers except for the asymptotes. Because you can't have a line on, you can't have a point on an asymptote. Asymptotes are like no man's land. Okay? They repel. They don't let things be on them. Okay, so then the same thing for the range. Okay? The range starts at the very bottom at -infinity. So then my pink graph is coming up, 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 and it's not going to touch who? It's not going to touch 2, is it? And it jumps over 2, and then it goes up, 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 up again. Okay? So then it jumps over 2, and it goes up, up, up again. Or you can say that the range is all real numbers except y is not equal to 2. Okay, so let's go back over here and do this problem. Okay, so the domain of this problem. So domain is right and left. So here's the graph. It's coming in, it's coming in, it's coming in. It's not going to touch who? 2, okay? So it's all real numbers except x is not equal to 2. I like to write it this way because it's easier to me, but you'll see it written like this sometimes. And I want you to be familiar with that in case another teacher down the road asks you to write it like that or something. Okay, so let's talk about the range. So it's every number. This black graph is going to be every number going up and down, except it's not going to be what? 4. Okay? So it's all real numbers. Okay? It's all real numbers, except y does not equal 4. So you might write it -infinity to 4, and then 4 to infinity. Okay, so let's do another one. Okay, so here you got to take a minute to get your eyes to do the right thing. Here's the origin, and this graph moved here. So how did it move? How did it move? It moved down 3, and is that your H or your K? Is that your H or your K when it moves down 3? That's your K. So down 3. Okay? How did it move right or left? It moved to the left 1, so that's a minus 1. It'll be a plus 1. It'll be a liar in a minute when we put it into the equation. Okay, the A. Okay, normally this graph would be about right here and about right here, but it's not. It's been smushed. It's been compressed in. So it's going to be a number less than 1. What's it going to be? A half. Okay? Okay. Now, where's our horizontal asymptote? What's it doing? Y equals -3. What's the vertical asymptote? X equals -1. See, look, these are the same numbers. Okay? The name of this point right here is -1, -3. Okay? You just keep using the same numbers over and over and over. Okay? So, my function is the A comes first. What is our A? A half. 1 divided by X minus H. What's H? -1 and then minus 3. But some of y'all are like dying to say it. What are you dying to say about this? It's going to be a positive. Okay, so I just kind of drew it out like that just to show you why. Okay, so our domain is all real numbers except X. Remember, y'all know for domain you use X's, for range you use Y's. We've been doing that for years now, okay? So our domain is all real numbers except X does not equal, did I put a not equal sign on that last one? Okay, X does not equal what? -1, and Y does not equal -3 because those are our asymptotes. The graph is jumping over those asymptotes, okay? Okay, so the last thing is this, and you have this on your worksheet. You have a little chart on your worksheet. It asks you to state the vertical asymptote and the horizontal asymptote. Well, our vertical asymptote is related to our H, and our H is found in the domain, okay? So you have to set your domain equal to 0. But that's a big old D. Okay, what do we have to do with this? What do we have to do to this? First. Yeah, we have to factor it. Don't tell me that it's 9. Okay, you have to factor it first. This is one of those easy factoring problems that's difference of two squares. So, what is X? -3 and +3. So our domain is, our vertical asymptote is X equals 3 and X equals -3. We actually have 2 vertical asymptotes in this situation. And we'll talk about that next week. Okay, the horizontal asymptote is just your K value. You just say Y equals whatever the K is. What's our K? -6. So you say Y equals -6. Okay? So you have a little chart like that you can do like really super quick on your worksheet. Okay, let me